Do you feel the vibes?
All right. So when we had systems of equations with two variables, right? And if they were linear, those would give us two lines. Each linear equation in two variables would give us a line. So two of them would give us two lines. Okay? Put everything else away. And then their solution, right? If it's an equation, their solution is a point where the two intersect. Now, if I have three equations, then each of the three equations is not a line, it's a plane, right? And so, like if you can see around the room here, like each of these walls, the ceiling, the floor are a plane, right? So now, if I have two planes intersecting, right? Like for example, if you look at the plane of the ceiling and this wall ahead of us, those two planes intersect at this line, right? So intersections of it will be a whole line, and then you have like infinitely many points on that, right? So that's how two planes can intersect. However, if we look at three planes, right? So look at the plane of the ceiling, and also the plane of this whiteboard, and also the plane of these windows, right? One plane, two, and then three. These three planes intersect at that one corner up there, right? So, and the intersection of these three planes is one point in space. So the solution would just be one coordinate in space, right? So that's how you will get one solution. Okay, now it could also be, right? Like if you have this situation, like the pages in a book, right? All three of these planes intersect each other along this line over here, right? In this case, you can get infinitely many solutions. It's not all reals again, but all the solutions are along that one line that all of these things intersect through. Or you could have three planes lying on top of each other, right? Just like this one. Then you get also infinitely many solutions. Okay, so how do you get no solution? You get no solution when there is not a single point where all three intersect at the same time. So if you look at the far right one, this one, right? It's like look at the ceiling, the floor, and then the floor underneath us. Those planes will never intersect, so there is no solution, right? If you look at this middle one, okay, there is an intersection here, there is an intersection here, but there is not a place where all three intersect, right? So that's no solution. All right, so now, how do you solve a system of three equations? You have to eliminate one variable by using two different pairs of equations. So if you have x, y, z, you have to get rid of one of them, and then it just becomes two equations, and then we substitute. Okay? Now, let me say one other thing. If you have three variables, x, y, z, or a, b, c, however many variables you have, that's how many equations you need in order to solve it. If you have three variables but two equations, you can't solve. Okay? All right. So take a look at this one. I have x, y, and z. So what I'm going to do is first try to get rid of one of the variables. All right. The first thing I do is I want to label my equations 1, 2, and 3. Because you know what? I want to be able to like show my work and keep track of what I'm doing. So you first have to decide on what variable to get rid of. When I scan this, you see the bottom z has a coefficient of -1. That's how I would decide to get rid of the z's. It's just easiest. So now you're going to use a pair of equations together to get rid of the z. I'm going to do 2 and 3. So equation 2 is negative 3x plus 5y plus 2z is equal to negative 27. Now look, what should I multiply equation 3 by to get rid of the z's? 2. So I'm going to say 2 times equation 3, and that's going to be negative 10x plus 6y minus 2z equals negative 34. Now, let's add. The z's go away, so I have negative 13x plus 11y equals negative 61. Okay, now I need another pair to get rid of the z's again. I used 2 and 3. I can't use 2 and 3 again, but I could use like 1 and 3 or 1 and 2. Okay, so why don't we use 1 and 2? What should I, okay, so equation 1, I'm sorry, 1 and 3 is what I'm going to use. So equation 1, let me write it. 2x plus 4y minus 5z equals 18. And then I'm going to use equation 3 again. What am I going to multiply it by? 5.
Negative 5.
Oh, negative 5, yes. So it'll be 25x minus 15y plus 5z equal to 85, right? Right?
Oh, there's still more.
Okay, so when I add these, I get 27x minus 11y equals to 103. Okay, now I have two equations with the same variables. I take this one and this one together, and let's see, negative 13x plus 11y equals negative 61. 27x minus 11y is equal to 103. Oh my gosh, look at how wonderfully that worked out. Right? So these cancel out. So I get 14x is equal to 42. X is equal to 3. Okay. Now, I got x. Now I have to take the x, plug it into one of these double ones, and then find the y, and then plug it into one of the triple ones, right? So first this is called back substitution. You just go back and then back. So why don't we plug it into, yeah, the first one. So negative 13x plus 11y is equal to negative 61. Negative 13 times 3 plus 11y equal to negative 61. 11y equal to negative 22. Y is negative 2. Okay, still not done. Now we need z. I'm going to use that third equation for z. Negative 5z plus, negative 5x plus 3y minus z is negative 17. Negative 5 times 3 plus 3 times negative 2 minus z equals negative 17. So eventually, negative z is equal to 4. Z is equal to negative 4. So now I got x, y, z. We go in alphabetical order. My coordinate will be 3, negative 2, negative 4, in parentheses. That's my answer.
That takes up a lot of space.
Yeah.
Oh my god.
Okay.
That's really
All right.
clever.
So
How many
now,
of those problems would there be on the test?
one or two.
How many of those on the homework? All
Well,
those?
let's.
Yeah,
when
all
you-
of them
when
are.
you mess up just the x or the y.
That's
Yeah.
6 different
That's
times we do
painful.
that. on the
Yeah.
homework.
So don't mess up. This is stuff that, you just have to make sure you are like focused, your mind is on what you're doing, you're not, texting at the same time as you're working, right? Okay, so another thing, right, about writing down steps. Do you see how I show my work? This isn't just showing my work. This is also, if I made a mistake, this bookkeeping lets me go back and retrace my steps, right? So make sure you write all that. Okay, by the way, somebody hasn't put their cell phone in the pockets.
Must be.
Yeah, okay. All right, let's go on to the second one. So we're gonna label these 1, 2, 3. And remember, you're always getting rid of the same variable in the first steps. Okay, so which one do you think we should get rid of now? X. I want to go with the X. Yeah, let's use 1 and 2. So 1 is 4x minus 3y plus 6z is 18. What am I going to multiply 2 by? 4. So negative 4x plus 20y plus 16z is 48. What do I get?
192.
Yeah, oh, sorry, 192. So 17y plus 22z is 210. Cool?
Yes. Very cool.
Okay, now I'm going to use which two?
2 and 3.
2 and 3. Or you could do 1 and 3, but that's a lot more work. So I'm going to multiply 2 by 6. Negative 6x plus 30y plus 24z is equal to 288. And then 6x minus 2y plus 5z equals 0. Okay, x's went away. 28y plus 29z equals 288. Okay, right? YZ. Okay, so now let's write them together. 17y plus 22z equals to 210. 28y plus 29z equals to 288. Okay, and so now we have big numbers. So what? It's okay, right? On the homework, you can use your calculator to multiply. On the test, it won't be like this big. So I'm going to get rid of the y, right? I'm going to multiply this top one by 28 and this bottom one by negative 17.
Big numbers there.
I know. So it'll be 476y plus 616z equal to 5,880.
There's more numbers to go around there than needed.
And then negative 476y minus 493z is negative 4,896. I know. Okay. 123z equal to 984, so z is 8. Okay. So let's find z, right? So I'm going to plug it into this first equation with the 17y. 17y plus 22z is equal to 210. 17y plus 22 times 8 is 210. 17y plus 176 is 210. So that's 17y equals 34, and y is 2. That's it, right? So now I need to find x. I'm going to use equation number 2 to find x. So that's going to be negative x plus 5y plus 4z equal to 48. Negative x plus 5 times 2 plus 4 times 8 equal to 48. So let's see, 10 plus 32 is 42. So negative x is equal to 6. X is negative 6. So finally, negative 6, 2, and 8. Right? And so this is a specific point in space, right? And if I were to like draw where this is, okay? So suppose this is the x-axis and this is the y-axis, right? I would go negative 6 up 2, and then 8, positive 8 would be like, yeah, coming out of the board, right? Or into the board, depending on, right? Coming out, so it would be like here, okay? So that's how you could figure out where it is, right? No, we're not going to graph it. Okay. Okay, so here we go. It would actually not be coming out of the board. The way I've drawn it, it would go like this way. So, like into the board. Okay. For this one now? Okay, yeah. Okay, yep.
Will we get equations with more than 3 variables?
No, that's too many. It's too much time.
My grandfather
No.
actually figured out he made in college he made a code that could just solve all the
Oh, very cool.
It was like 4 plus or 5.
Very cool.
He told me about it when I was learning too.
Okay. All right, so let's do this one. So what should we get rid of? The x's? So multiply.
The y.
You could do either or. Let's do x.
The y.
Okay. So 2x. So we're going to take the first one. 2x plus y minus 3z is equal to 5. Then the second one, I'm going to multiply by negative 2. So negative 2x minus 4y plus 8z is equal to negative 14. Negative 3y plus 5z is equal to negative 9. And now I'm going to, which one? 2 and 3?
Yeah.
So multiply 2 by what? Negative 6? Okay, let's go ahead and do that. What are we trying to get rid of, x or y?
Oh, yeah.
Okay, so let's add, and then we'll meet again when we finish this step. Okay. Right, so I got negative 9y plus 15z is equal to this. So now I take both of these, negative 3y plus 5z is equal to negative 9. Negative 9y plus 15z is equal to negative 27. I'm going to multiply by what? Negative 3. So for the bottom one, that remains unchanged. The top one becomes positive 9y, negative 15z, equal to 27, right? And look at that. I get 0 equal to 0. So what is that? Infinitely many, not all real numbers. Infinitely many solutions, not all real numbers. If you say all real numbers, that means all, like these are like all of the planes and like it just doesn't make sense. Okay, infinitely many solutions. Okay, let's go ahead and do this next one.
I can tell that 1 and 3 are equal.
Okay, so let's do 1 and 2, right? So 1, I'm going to multiply by -2. So what do I get? -6x plus 2y plus 4z equals -8. And then equation 2, I got 6x minus 2y minus 4z equals 11. Right? So if we do this, right, so you're going to get 0 equal to 3, right? But we know that 0 is not equal to 3. So we get no solution here. Now, I need to tell you something else. So we know that no solution can look, different, right? You have 3 different situations of how no solution can look. So if you're in this situation here, no matter what 2 equations you use, you're always going to get no solutions from the get-go. But suppose you have a situation like these other 2, right? Where if you happen to, like in the first case, right, this one, if you happen to choose the equation for the yellow one and the green one, there will be a solution there, right? Because those 2 intersect. So it could be that for the first one, you get a solution, like you have to go several steps before you realize it's no solution. You see what I mean? And you will never know, which one of the situations you're at. Or like, for example, this middle one. If you choose blue and green, you get no solution from the first one. If you choose green and yellow, you're going to get infinitely many, then it turns into no solution. So there is no way to know from the beginning, right? So you just have to kind of like be in it. But just so you know, like if the answer in the back of the book is no solution, but you seem to have been getting infinitely many, how do you know? You just have to kind of keep going. You know what I mean? No, because I know that's not going to go anywhere. Like that one ended. But what happens is, that one ended, right? Right? Yeah.
This one's a really weird tangent.
Yeah.
It's like a choose your own adventure, but if you
Press start.